So yesterday in class, you watched a video in one of the stations, you took a formative in the other station, and you worked on some review problems from 6.3 in the third station. Okay? So the video was the 4 steps that are needed to find an inverse. First, you switch it out of function notation and make it be y equals. Then, you switch the x and the y. Then, you solve for y. Then, you put it back into inverse function notation. Okay? So that's the 4 steps. Okay? Today, we're going to take that a step further. We're still going to find some inverses, but if you truly want to prove that a function, or that 2 functions, I should say, that 2 functions are truly inverses, you have to use the composition property of inverses. And you have to show both. So if f of x and g of x are inverse functions, then f of g of x equals x, and g of f of x equals x. And in order to truly prove that they're inverse functions, you have to show both of those. Okay? You have to put f into g and get out x, put g into f and get out x. If you get out something else, they're not functions. If they're functions, the only thing you're going to get out is x. Okay? Let's try it. So, verify that the functions below are inverses. F of x is equal to 4x plus 2. G of x is equal to 1/4 x minus 1/2. Okay? So if I'm going to verify that those 2 are inverses, the first thing that I need to show is I need to show that f of g of x is equal to x. So that means that I have to show that f of 1/4 x minus 1/2 is equal to x. Okay? Well, that's going to be 4 times that plus 2. Using the distributive property, 4 times 1/4 is 1, times x is x. 4 times 1/2 is 2, so that's going to be minus 2 plus 2. So that one equals x. Okay. Now, you're going to say, well, they're inverses. And then it's going to come to Tuesday's test, and I'm going to mark it wrong. Because why? But you got to check the other one. You have to show them both in order for it to be verified. So then now you've got to show g of f of x also equals x. So that's g of 4x plus 2. So that's going to be 1/4 times 4x plus 2 minus 1/2. Again, using the distributive property, 1/4 times 4 is 1, times x is x. 1/4 times 2 is 1/2. minus 1/2. 1/2 minus 1/2 is 0. So then that just becomes x. So now you can definitively say that f of x and g of x are inverses. Oops, I forgot to save that one. Tap. Okay, that I like better. So, find out if f and g are inverses, and if they're not, find the actual inverse of f of x, and verify that it is the inverse. Okay, go for it. Okay. So if I want to prove that f and g are inverses, then f of g of x has to equal x, right? So that's going to be f of 1/3 x plus 1 So that's going to be 3 times 1/3 x plus 1 minus 1. 3 times 1/3 is 1, times x is x. 3 times 1 is 3, minus 1 gets me there. That tells me that this is x plus 2. Are f and g inverses? They are not inverses. Automatically right now they are not inverses. Because x is not equal to x plus 2. So I'm done. I don't have to show the second one because they're not inverses. Okay? So, then it said, find the inverse of f of x. Well, f of x was equal to 3x minus 1. First thing we do is we set that equal to, or switch out f of x with y, I should say. Then we switch the x and the y. Then we solve for y. And lastly, we change the y into inverse notation. Now, let's verify that those are inverses. So now I would say f of the inverse of x has to equal x. So that's going to be f of x plus 1 divided by 3. The 3 times the dividing by 3 cancels that out. So that becomes x plus 1, then minus 1, which is just x. Good so far. Now I have to show that the inverse of f of x also is equal to x. So that's going to be the inverse of 3x minus 1, which is going to be 3x minus 1, then plus 1, all divided by 3. 3x minus 1 plus 1 is 3x. 3x divided by 3 is x. So we verified now that what we learned from yesterday does in fact give us the inverse functions. I put the inverse into f, and I should get out x. Then I put f into the inverse, and I should get out x. Huh?
I just gave my nuts away.
Find the inverse of f, and then verify that they are inverse functions. Switch it out of function notation. Switch your x and your y. Solve for y. Switch it back into inverse notation. Okay. Then it said, verify that they are using the composition rule. So, first thing we have to show is f of the inverse has to equal x. So that is f of the cube root of x minus 1. So that's going to be cube of a cube root. Cancels each other out, right? Okay. So then that leaves me with x minus 1 plus 1, which is just x. Then I have to show that the inverse of f is also equal to x. So that's going to be the inverse of x cubed plus 1. So that is going to be the cube root of x cubed plus 1 and minus 1. X cubed plus 1 minus 1 is just x cubed. So this is the cube root of x cubed. The cube root of a cube is, or does what? Cancels each other out. So that just leaves me with x. So we've verified that this is our inverse of our original function. Okay. Earlier this year, we played a game called Function Not a Function, okay? Where there was one rule to the game, and that one rule was if function. If I'm looking at a graph. Vertical line test. What do I do with the vertical line test? That what I'm looking at is a function, right? Okay. So the first rule in our game today, function not a function, is that if I use the vertical line test, what I'm looking at is or is not a function. If it only touches my vertical line in one spot, then it is a function. If it touches in two, not a function. Okay. I'm going to add a rule today, and that rule is the horizontal line test. Okay. So, how are vertical and horizontal related? They're perpendicular. Is that it? Think about what we're doing today and what we did yesterday. They're what? They're inverses. Okay? So what do you think the horizontal line test would tell me? Vertical line test is going to tell me what I'm looking at, a function, not a function. If my inverse is a function or not. Yeah. Okay. The horizontal line test is going to tell me if the inverse of what I'm looking at is or isn't a function. So vertical tells me what I'm looking at. Horizontal tells me if that's inverse or if its inverse is a function or not. Okay. Let's try one. F of x equals 2x squared. Based off of your knowledge, what should that graph look like? What do you have to see? It goes, the sides go up the same direction. Okay. Anything in the middle? Parabola, right? Okay. And it should be going up, right? Okay, because we got a positive lead coefficient. So it should look like that. Right? Okay. This is what it actually looks like, which is what we determined. Okay? So that's what it should look like. Is f a function? Is f of x a function? Yeah. Okay, we use the vertical line test, right? Let's go. Okay. So there's my vertical line. I slide it across. Only it's touching in one spot. We should make that line a little thinner so that we can see it a little bit better. Slide it across. Only ever touches in one spot. Okay? So yes, f of x is a function. Okay? What about the inverse of f, is it a function? Why not? Touches in two spots, right? Touches once here, and it touches once there. And I only need one failure to make it not be a function. So the inverse is not a function. What is the inverse? What is the inverse of f of x? So we switch them, right? Or y equals 2x squared. X equals 2y squared. Divide by 2. Take the square root. Right? That one's not a function. What about that one? What should that one look like? They're going to go opposite directions, right? If I'm going to the right, up or down? I'm going to the right. Up, because it's got a positive coefficient, right? Okay. Is there a hump in the middle? Yeah? So does it look like, so the question is, does it look like this? Or does it look like this? Why option 1 and not option 2? Nope, it's not the Lie coefficient thing. The Lie coefficient thing tells me which the sides. But nope, that only tells me one specific point. Doesn't have an x squared or an x term, right? Okay. The more terms you have, the more humps you have. Okay. This doesn't have a quadratic or a linear term, so therefore it doesn't have a hump. So, is it a function? Yeah, that's a function. Vertical line test says so. Is its inverse a function? It is. Yeah. I didn't zoom in very well, but if you take this area right in there, it looks like that if you zoomed in on it. Okay. So it doesn't cross over. So yes, the inverse is a function. What about this one? What should that one look like? Not a straight line. Sure. A V up, a V or a mountaintop? A V. Okay, because it's an absolute value, so it should look like a V. All right. Is H a function? H is a function. Oops, I put h of x. I don't want to put h of x. I wanted to put yes. Is the inverse a function? What's up? H is a function because nope, because of the vertical line test. It only ever touches in one spot. Okay? H is the inverse of H is not a function because, oops, let's move it down like that then. Because there it touches in two spots. Okay? On your line test, it can only touch in one spot. Okay? Now, for this homework, there are 3 graphs. If you want to put them on graph paper, that is your choice, but they can also just be sketches in on your normal sheet. Okay? And the last class decided that this was due on Tuesday.